Yes, students, today we will do graphical derivation of equations of motion. In the previous classes, we have seen the numerical derivation and different graphs. Now we combine this and today we will do graphical derivation of equation of motion. First, we will derive the first equation of motion. One thing you have to notice in the previous derivations, in the previous graphs, what we have seen, we taken initial velocity as 0. But in the graphical derivation, we cannot take initial velocity 0. There must be some value and that is point A. Suppose body is at A with initial velocity A. So, this OA is your initial velocity U and the final velocity is at point B. So, this BD is your final velocity V, right? One more thing you have to see, this AO is equal to CD and this EO is equal to BD, right? So what we will see, we can write AO is equal to CD, which is equal to initial velocity, and this EO is equal to BD, which is final velocity, right? Now see where we have to start the derivation. We have to start the derivation with BC. What is BC? Okay. So this BC is equal to, what we will see, BC is equal to BD minus CD. So BC is equal to BD minus CD, right? And what is BD? BD is V and CD is U. So BC is equal to V minus U. This is the first part of your equation, right? Now we will see where we have to start the derivation. What is BC? You see, what is BC? So BC we have seen, BD minus CD, that is V minus U. Now one thing you know, what is acceleration? Acceleration is change in rate of change of velocity, that is A is equal to change in velocity, that is change in velocity upon time. This is your acceleration. And see the graph, what is change in velocity? First the velocity is CD and then the velocity is BD. So what is the change? Change is BD minus CD. So change in velocity is BD minus CD, right? And BD minus CD, what is BD? BD is V and CD is BD minus CD. BD minus CD is BC. So write BC by T. So A is equal to BC by T or AT is equal to BC. Now put the value of BC in this equation. What you will get? AT is equal to V minus U, or when you arrange it, you will get V is equal to U plus AT. This is your first equation of motion. Let's repeat. We will do graphical derivation. In this, what we have to see, you cannot take initial velocity as 0. Suppose initial velocity is A. So AAU is the initial velocity and BD is the final velocity, because B is the point where the final velocity is lies. Okay. So AO and CD are equal and EO and BD are equal. So AO is equal to CD, which is equal to U, initial velocity, and EO is equal to BD, which is final velocity. Now we start our derivation with what is BC. BC is BD minus CD, that is BC is equal to V minus U. Now we know that acceleration is equal to rate of change of velocity. So A is equal to change in velocity upon time. And what is change in velocity? See the graph. Our final velocity is BD and initial is CD. So what will be the change in velocity? Change in velocity is BC. So BD minus CD by T, that is BC upon T. So acceleration is equal to BC by T or AT is equal to BC. को क्रॉस मल्टीप्लाई करेंगे तो AT is equal to BC. So AT is equal to V minus U. ये कहाँ से आया? We put the value of BC in equation, this equation. You get AT is equal to V minus U. And when you rearrange it, you will get V is equal to U plus AT. This is the derivation of equation.